to add two sets? Not really. However, there is something similar. If we want to combine two sets to get a collection of objects that are in either set, then we can take the union of the two sets. Symbolically, that looks like this. C, which is our combined set, is the union between A and B. This reads that C is the union of A and B. That means that the elements of C are exactly the elements which are either an element of A or an element of B, or an element of both, technically. That could be as a possibility as well. For example, if A equals the set 1, 2, 3, and let's say B equals 2, 3, 4, then that means that A union B is just 1, 2, 3, 4. The other common operation on sets is intersection. We write, in this case, it's almost the same. In this case, instead of that symbol, it would be this symbol. Oh, let's try that again. There we go. And that should come all the way down. There we go. All right. And then in this case, we say that C is the intersection of A and B, when the elements in C are precisely those both in A and in B. So if A equals 1, 2, 3, and B equals 2, 3, 4 again, then this means that A intersection B, is specifically 2, 3. Often, when dealing with sets, we will have some understanding as to what everything is. Perhaps we are only concerned with natural numbers. In this case, we would say our universe is n, which sometimes I'll write as that as well. Sometimes we denote this universe by U as our universe. Given this context, we might wish to speak of all the elements which are not in a particular set. We say B is the complement of A, and we write specifically, I'm going to give myself a little bit more room here. We say that B is the complement of A, when B contains every element not contained in A, and sometimes we write A with a bar over it. So if our universe is, let's say, all the integers from 1 to 10, let's say our universe is 1, 2, all the way up to 10. And let's say A equals, let's pick 2, 3, 5, and 7. Then that means that the complement, which we would write A bar, is going to be 1, 4, 6, 8, 9, and 10. Of course, we can perform more than one operation at a time. For example, consider A intersect B complement. This is the set of all elements which are both elements of A and not elements of B. What have we done? We've started with A and removed all of the elements which were in B. Another way to write this is this with set difference, which we label as A backslash B. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. It is important to remember that these operations, union, intersection, complement, and difference, on sets produce other sets. Don't confuse these with the symbols from previous videos, like element of and subset of. A intersection B is a set, while A, and actually I'll write this out real quick. A intersection B is a set, whereas A subset B is not a set, it's either true or false. This is the same difference as between 3 plus 2, which is a number, and 3 less than or equal to 2, which is false. In the next video, we're going to discuss the Cartesian product. So I'll see you all then.